Hello students, today's agenda is to check homework. We'll be learning about inequalities and you will be able to do 4.9. Today students will be able to create linear inequalities in two variables from scenarios and state constraints. In the previous lesson we learned about equations. I'm going to start with a similar example in here. It says a monkey has 16 hours to work every day. He can spend 2 hours getting a bunch of bananas, or he can spend 4 hours hunting for small animals. How many of each can he find during a day if he spends his entire day looking for food? So in here, when it says that we have to use the entire clay, like we saw in the previous video, or that you have to spend the entire money, or in here that he's going to use his entire day or hours doing this activity, that's when it's an equation, okay, equal to that amount. So to write an equation, we know that this monkey spends 2 hours looking for bananas and 4 hours hunting for little animals, okay? So what we're going to represent in here for our equation is that the 2 hours spent for bananas, I'll just do a capital letter, plus the 4 hours hunting for small animals is going to be equal to exactly 16 hours. So that's how you will represent it with an equation. We know because he uses the entire 16 hours. And so to graph, if you recall, when we have the two variables on the left of the equal sign, that's in standard form, okay? Standard form of the equation, and that means that we can use the x and y intercepts to find the points where the line intercepts my x and y axis. So we're going to put b a, and so when a is 0 and they're closer to the center, okay, so when a is 0, that means 4 times 0 is 0, so all you have to do is divide the 16 hours only by the 2 hours that takes to search for bananas, because you're not looking for animals, right? That means that 0 hours are spent on searching for small animals, so the 16 hours divided by the 2 hours that takes to search for bananas gives you 8. So he gets 8 bunches of bananas. For the other one, when b is 0, 2 times 0, so that means he's not searching for bananas, he's only spending his time searching for small animals. 16 divided by the 4 hours gives you 4 small animals. And so we graph using those intercepts. Again, if you had to show your work, all you do is replace, because we start with the 0, 0. When you're finding the bananas, the small animals is 0. The opposite is 0. Okay, so 2b plus 4 times 0 hours spent on searching for animals is equals to the 16 hours. 4 times 0 is 0. That's why we covered it, because it basically disappears, right? So the 2 hours on the bananas plus 0 hours on animals is equals to 16. 2b plus 0 is 2b. Is equals to 16. And finally, if we're multiplying, the opposite is to divide. This is only if you have to show your work. If not, you can just go ahead and do it directly. 16 divided by 2 is 8. And so that's how you got that number right there. For the other one, when the monkey is not searching for bananas, you substitute that for 0. So 2 times 0 hours spent on that plus 4a equals 16. 2 times 0 is 0 plus 4 equal 4a equals 16. 4 plus 0 plus 4a is 4a is equals to 16. So he's searching animals only for small animals. So by dividing by the 4 hours it takes to find one, we can figure out how many he'll get. And 16 divided by 4 is 4. So he's able to find 4 small animals. The first one is always going to be on your x-axis. Since it's b, that means the bunches of bananas. And on y, you will have the small animals. Okay, and so we have 8 for the bunches of bananas. So 1, 2, 3, 4, 5, 6, 7, 8. It's right there. For small animals, you have 1, 2, 3, 4, and it's right there. And you can put more if we connect the 2 points. Look at what the intercepts are. This is what we've been talking about while we've been solving. So the 8, 0 represents that when he gets 8 bunches of bananas, he will get 0 small animals. Okay, when the monkey finds 8 bunches of bananas, he finds 0 small animals. And for the other intercept, 0, 4, which is the y-intercept, when the monkey finds 4 small animals, he finds 0 bunches of bananas. And for the constraints, again, the domain refers to the values, possible values of x. And I know I extended the line in here, but it doesn't make sense to say that there are negative bunches of bananas or that there are negative small animals. No, so it will be always greater or equal than 0, but x is also less or equal than 8. If he only has 16 hours and it takes 2 hours to get a bunch, then he can only do 8 bunches of bananas. Okay, so it has to be less than that. For the range, which refers to the values, the possible values of y, it would be the same. You cannot have negatives, so it's going to be greater or equal than 0, but less or equal than 4 small animals. With 16 hours, he cannot find more than 4 small animals because it takes 4 hours to find one. That was the equation, but before we go on to the inequalities, let's go over some vocabulary. Less than means you use this symbol. More than, you use this symbol. At most, even though it sounds like the word more, in reality is less or equal to, because that's the limit of at most. That's the most that I'm going to give. At most, I'll pay you $1,000 for this car. Okay, the limit also, if there's a limit for people in a room, that's the maximum. That's the limit. You have to have that amount or less. The maximum amount of soap that you can use is this amount, or otherwise the bubbles are going to come out of the washing machine. Okay, so that's the maximum. You need to put that or less. And again, sounds like more, maximum, those sounds like greater than, but in reality, no, it's the opposite. For this one, at least, I want to earn at least $26 an hour. That means that I want to earn more, equal or more than $26. That's why it has the equal sign in here. The minimum that I want to earn is $1,000 a week. Again, this with the equal sign means I want to earn that amount or more. Okay? And again, don't get confused with the words least, which are close to less, but it's not. And minimum, it means quite the opposite. At least means that or more. The minimum, that or more. And so you will see here that it doesn't say use exactly that amount of money or food or time, or it says you have less than 210 pounds of food. You can feed a pig with 3 pounds of food or a horse with 5 pounds of food. How many animals can you feed? So you have less than that, okay? Less than. And you can feed a pig with 3 pounds and a horse with 5 pounds. So it says create an inequality. First of all, we're using the word less than, so that already gives us the idea that it's an inequality. And so in here, it says the pigs are fed with 3 pounds. The horses are fed with 5 pounds. And you have less than 210. And it says how many animals can you feed? Well, to be able to find out, we need to divide the number of pounds by the number of pounds that each animal eats to see how many I'm able to feed of each, the pigs and the horses. So let's see. Let's say that these are pigs and horses. Pigs and horses. And so I put the 0, 0. If I don't feed any of the horses, right? If I don't have any horses, I just feed the pigs. 210 divided by 3, that's 70 pigs. When I'm not feeding pigs, I only have horses. 210 divided by 5. 5 goes into 21 4 times. 4 times 5 is 20. Carry 1. 10 divided by 5 is 2. So 42 horses. Or you can use your calculator. So this is my x-intercept and my y-intercept. Those help me to sketch my graph. The restrictions are saying that the domain, again, for the domain, which is for the x, and so you can put p or you can put x. We cannot have a negative value for pigs, so we're going to say that x is greater or equal than 0. But then we're looking here for p is 70, but it has to be less than 70 because we have less than 210 pounds. The range for the y, which represents the horses, is greater or equal than 0 as well because we cannot have negative horses, but it has to be less than 42 horses because I have less than 210 pounds of food. Now we put here for our graph, pigs on the x-axis, horses on the y-axis, and we're going to put 10, 20, 30, 40, 50, 60, 70, and it's 70, 0. And then for the other one is 42, so 10, 20, 30, 40, 50, so somewhere around there. Because this inequality doesn't have the equal sign, we're going to have a broken line. Less than or greater than, it's a broken line. But if it has the equal sign, even if it's greater or less than, then the line is going to be solid. Okay, so broken line and solid line. This is with the greater than or less than. Okay, it doesn't have the equal sign, so my line is going to be broken. So for the horses, it's going to be less than 42, so it's below that. For the pigs is less than 70, so less than that. But the fact that we have these constraints, x is greater than 0 and y is also equals or greater than 0, we can say that the shade will stay within these parameters. Okay, less than the 42 for the horses, less than the 70 for the pigs, but greater or equal than 0 for each one of them, so it stays within that. Okay, number 3 says you have more than $264. You can buy $12 shirts or 33 fancy pants. How many of each could you buy? And so again, we have $12 shirts, $33 fancy pants, and you have more than 200. So more than is, it doesn't have the equal sign again, so it's more than 264. So to be able to find the restrictions, and for the graph we can use the intercepts. And so this will be my shirts and my fancy pants, shirts and fancy pants. And so if I buy 0 fancy pants, 264 divided by 12, I'll go ahead and use my calculator. It's 22. And for the fancy pants, that means that I don't have any shirts. It's 264 divided by the price, which is $33, equals 8 fancy pants. So what does that mean for the restrictions for the domain? And I wanted to do the restrictions first, but let's do the graph first so that it makes more sense once I'm explaining the restrictions. So if these are the shirts and these are the fancy pants, let's do them by 2, even though it's going to take a little longer, but that's okay. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. And then for the other one, we need up to 8. So 2, 4, 6, 8, up to that right now, up to that only. And so that it doesn't, and so on. Okay, so we connect those. Again, because it doesn't have the equal sign, it's going to be a broken line. If it had the equal sign, it means that it includes the points on the line. But in this case, it doesn't, so it's a broken line. And so it says that the shirts and the fancy pants, together are greater than $260, greater than $264, because you have more than $264. Okay, so possibly you could have, again, we cannot have negative shirts, we cannot have negative fancy pants, so you limit yourself to not include those or those right there, okay, because you're gonna have negative shirts. So it's going to stay within these limits, okay, so up to here only. And careful, because you don't want to go over these either, okay. There you go. Now let's see what that's the domain. Well, we can have the shirts are going to be greater than 22. And for the fancy pants, which is the range, is going to be greater than 8. Now in here, by putting these inequality shades, this could represent many possibilities. For example, in here, it says this point will represent it's within the solutions, right? It's within the shade. So that means that you can buy 2 shirts and 12 fancy pants. And yeah, like any point in here, all you have to do is just substitute in your inequality 12 from here times the shirts, which I chose 2, plus, so this will be the price. This will be the price of the 2 shirts that I'm buying, plus 33, which is the price of a fancy pant, but I'm buying 12 of them. And that should be greater than 264. Okay, and so 2 times 12 is 24. 12 times 33 is 396, and it should be greater than 264. And you add the 24, which is 420. And is it greater than the 264? Yeah, so that's a possible answer. Now, of course, there are going to be other limitations in here. They're just telling you that you have more than that amount of money, that you can spend more than that, but it doesn't tell you a limit of less than what, right? So we don't know what other constraints we would have in here if we were limited to a certain amount of money. And with this, we end our lesson. If you can please support that channel by giving us a thumbs up, subscribing around here. This is the link to the entire unit. Here you will find the next lesson. Now you're able to do 4.9 and have fun.